Yan yung assumption. So in this particular case, we already are given the width and the depth. The effective depth that we are going to use is 650 mm. By the way, we are going to make use of the ACI code here. So if there is anything, any changes based on the National Structural Code of the Philippines that you have noticed of, just kindly take note of the design procedures. Okay, so and apply the new specifications. So according to this problem, the if the compression reinforcement is required, you will be placing it at a depth of 60 mm. So minimum, that means the minimum concrete cover is 60 mm. And if the compressive strength of concrete is given, so that means FC prime is also given, 30 megapascal. And then the yield strength of the steel is also given, 410 megapascal. So in your case, you would look for what minimum compressive strength of concrete you would like to use, FC prime, and also the value for the FY. So in this particular case, we already are given the 30 megapascal and the 410 megapascal for FC prime and FY respectively. So what we are going to do now is to design for the longitudinal reinforcement. If the bending moment required for the beam to support is 600 kilonewton meter. So that means in this particular case, we are given already the moment. In your case, you would have to find out what is the value of the moment that you would like to design. So in the sample, in the design that you're going to have, you have to know the bending moment. So in this particular case, we already are given the bending moment. So you have to take note of this, the width. This is the width, B, effective depth. So this is the effective depth. And then the compression reinforcement if required. So that means this is the minimum concrete cover. Okay, so this is minimum concrete cover. Okay, that's the minimum concrete cover. And then you have 30 megapascal. This one is what you call as FC prime. And then the 410 megapascal, this is what we call as FY. And we are going to design for the longitudinal reinforcement. So that means we are going to design for the number of reinforcing steel bars or the RSB. And the bending moment that has to be supported is 600 kilonewton meter. So let us assume that this is the ultimate moment that should be supported by the beam. So in your case, you're going to look for the value of mu. In this particular problem, we already are given the value of mu. So let me just share with you. Can you see my whiteboard here?
Yes po, ma'am.
Okay.
Yes, ma'am.
So we are given the section, and the section of the beam is a rectangular beam. We've got the effective depth, and we have the value for B. So the value for B here is 350 mm, and the effective depth is given. This is 600 mm. And the minimum concrete cover, this one is the minimum concrete cover. In this particular case, we are given 60 mm for the minimum concrete cover. So in your case, you can assume a value for B and a value for D, or you can proceed with the other procedure, yun dun sa unang sample problem na meron tayo, na hinanap ninyo yung width at saka yung depth. Pero pwede din kayong mag-assume. So that's the the advantage of having the design. So, kung magde-design kayo, pwede naman. Just make sure na at the end, pwede ninyong ma-analyze if the section should be reinforced with that particular number of bars. Dalawang klase ang reinforcement ng beam. Pwedeng tension lang, dito lang sa tension, or both in the tension and in the compression side. Most often than not, in actual construction, most often than not, in actual construction, reinforced for tension and for compression, both. Okay? So if there are cases where you don't need to provide compression reinforcement, nilalagyan pa rin ng compression reinforcement only to make sure that the stirrup will stay in its place. So para lang merong mapagkapitan, para meron lang mapaglagyan, mapag uh, lagyan dun sa stirrups, okay? Pero if in any case the reinforcement for compression is not required, then you can just provide a very minimal number and very minimal size para dun sa compression bar. So that would add anyway, it would add the strength to the section. So at any rate, this is designed for compression only, and we are going to check whether we only need to provide how many number of bars do we have to provide in this section or not. So we are given here the width, which is 350 mm. The effective depth is 650 mm. The FC prime is 30 megapascal. Fy is 410 megapascal. And the moment that should be supported by the section is 600 kilonewton meter. So the first thing that we have to do is to determine the design coefficient. So we start with mu. Mu is equals to theta fc prime bd squared w 1 minus 0.59 w, wherein m sub u is the ultimate bending moment, theta is the strength reduction factor, fc prime is the compressive strength of concrete, b is the width of the beam, d is the effective depth of the beam, w is the design coefficient. Okay. So for ductility. So in this particular case, because we already are given the width, the depth, FC prime, and then of course the value for theta for bending is only given by the code and specification, and you are already given the 600 kilonewton meter moment that should be supported by the beam, then we only have one unknown variable in this one, which is W. So we have 600 kilonewton meter. We given the 600 kilonewton meter. You multiply it by 10 to the 6 because we would want to be consistent with our unit. So the unit for the moment is kilonewton meter. So we convert this to Newton mm. You multiply it by 10 to the 6 to make it Newton mm. Multiply it by 1,000 to convert kilonewton to Newton, multiply again by another 1,000 to convert meter to mm. So that's times 10 to the 6th. And then you have theta, according to codes and specification, is zero point 0.9. If there are any changes in the codes and specification, you just make use of the new codes and specifications. Okay. Anyway, you have your NSCP already. So you have FC prime. Our value for FC prime is in megapascal. So this is 30 Newton per square millimeter. So we use 30 here. And the width is 350. And the effective depth is 650. So that means we will be able to determine the value of W. Paki-calculate nyo nga. Just help me calculate the value of W. You have 600 times 10 to the 6th divided by 0.9 divided by 30. 350 by 650. Yes, 0.15.
0.16, ma'am.
No, 0.15 para lang doon. So you have W 1 minus 0.59 W. You're gonna need to use the quadratic equation formula. Okay? Alam nyo pa yun, tandaan nyo pa yung quadratic equation formula. Kasi ito, meron itong W squared tapos merong W. So you're going to use the quadratic equation formula para mahanap ninyo yung value. Yung calculator nyo na ginagamit, merong quadratic equation. Pwede nyo yung gamitin yung value. Just help me determine 0.59 W. So this can be rewritten as 0.59 W squared minus W plus 0.15 equals 0. So you divide it by 0.59, the whole of this by 0.59, 0.59, 0.59. So you would have only one for the W squared. W squared minus 1 over 0.59 is 1.695 plus 0.15. To help me find what's the value for the W by quadratic equation. X is equals to plus or minus square root of B squared minus 4AC over 2A. So this is quadratic equation. You solve for W by quadratic equation. There. This is quadratic equation. You still remember this one? Ito yung quadratic equation. Paki-calculate nyo nga habang kinakalculate ko din. Meron na kayong idea kung anong value? Yung B,
0.7.
1.16 po.
it should be less than mga point something lang. Para mga
0.17
ganito
po.
lang, mga
0.1632 po.
almost ganito lang yung magiging value niya. Hindi siya
0.17
lalayo
po.
siya. 0.
1632.
Yung common sa inyo habang ginagawa ko itong
May B plus minus, negative B plus minus square root of B squared minus 4AC po yun.
okay, sorry. Plus or minus B
Opo.
Okay. Plus or minus b
Hindi
square
po,
root.
minus B lang po. Negative B plus minus po.
Ayun. Negative b plus or minus, sorry. Negative b plus or minus square root of 4ac. Tama yan. Negative b plus or minus square root of b is 4b squared minus 4ac. Sige nga, yung common sa inyo ha, yung common yun na makukuha. Negative b.
Ano?
0.16, 0.163, paki-check nyo nga
Opo,
ulit.
ma'am.
Point,
0.1632 po.
ayan, sige. 0.1632.
Tapos yung isa po, ma'am, ay
Ano yung isa? Yung pag mas malaki, hindi nyo 1 point
1.53 po.
something, ang gagamitin nyo yung mas maliit na value. Yung 0.16. So, dalawa yung magiging value, pero ang gagamitin nyo yung mas maliit. Use W is equals to 0.1632. Okay. So, once you have computed for the value of W, you can continue doing the value of rho. Okay, you check for the, after you have the value of rho, W, you can now check on the steel concrete ratio. Okay. So for the steel concrete ratio, we are going to use the formula rho is equals to W FC prime over Fy. Okay. So we have rho is equals to 0.1632. FC prime is 30. Fy is 410. What is the value for rho? This is the steel concrete ratio that we have to provide in this section. Times 30 over 410. 0.012. Okay. So we are going to check with the minimum and the maximum value if it is within the minimum and the maximum. So we check with the maximum. The maximum is 75% of raw balance. So remember, we are to design in the balanced steel condition. So when you say balanced steel condition, we have to check on this steel concrete ratio, which is in balanced condition. That is rho B. So steel concrete ratio is AS over area uh, of the concrete. So area of the bar, AS, divided by the area of the concrete. So that is steel concrete ratio. So we are going to check for this, the balance steel concrete ratio. 75% of that is the maximum steel concrete ratio. Then we are going to check also with the minimum concrete, with the maximum or the minimum. Okay. So we are going to check whether we have provided enough steel concrete ratio. So raw maximum is 75% of raw balance. Raw balance is 0.85 FC prime beta 600 over Fy times 600 plus Fy, wherein the value of beta is 0.85 because Fc prime is more than is 30 megapascal. Okay. So we have the maximum steel concrete ratio is 0.75 times 0.85. Fc prime is 30. 0.85 for the value of beta. And the value for 600 is constant. Fy is 410. 600 plus Fy is 410. So that means the maximum steel concrete ratio that we have is 0.85 times 30 times 0.85 times 600 times 0.75. 600 plus 410. 0.0236. That is the maximum steel concrete ratio. So you have 0.0236 for the maximum steel concrete ratio. Now after this, we are going to check within the minimum and the maximum. The actual should be less than the maximum in order for us to say that this is reinforced for tension only. If in any case, the steel concrete ratio actual is more than raw maximum, then that means we need to reinforce the section for both tension and compression members. But in this case, because we have rho is 0.012, which is less than 0.0236, then that means tension only. So we only need to provide reinforcement at the tension side only. Okay? In that particular case, then you have to continue doing, okay? So you have to continue doing the area of the steel. So the area of the steel is equals to rho times B times D. So you're going to use the actual width and the actual depth that you have provided in the section. Area of the steel is equals to 0.012. Width is 350 mm. Effective depth is 650 mm. 650 mm. So area of the steel bars is 0.012 times 350 times 650. 2,730. 2,730 square millimeter. Then, let's say for example, the section, the dimension of the RSB, pwedeng kayo na rin yung mag-decide kung anong size ng RSB ang gagamitin ninyo. Okay, let's say we are going to use 28 square millimeter RSB. Okay. So, we need to determine how many bars do we have to provide in the section. The number of 28 bars, you multiply it by the area of 1 bar, pi d squared over 4. So that is 28 squared. And that should be equal to the area of the steel. So you can determine the number of 28 bars that you have to provide in the section by 2,730 total area of the steel requirement. Yeah, times 4 over pi over 2080 squared. So 4.4. So that means we need 5 pieces. 5 pieces of 28 mm diameter RSB. So that five pieces of 28 mm diameter RSB should be provided in the section. So if you are going to draw the section, you have to provide 5 pieces of RSB here. 5. Anyway, kung 38 mm yon, 28 mm, 28 mm times 5 minus concrete cover of 40 sa magkabilang side, 80, divided by 1, 2, 3, 4. So, meron ka pang 50 mm sa pagitan. Kung 50 mm sa pagitan ng bawat isang bakal, might as well gawin mo dalawang layer para magkaroon ng ng section dito. Kaya 350 mm. So 28 times 5 is 140. So 350 minus 140, 200 minus 80. So may 130 divided by 4. May 32 mm pa naman pala. So pwede pa yon, kasya pa kasi 25 mm naman yung pinakamalaking size ng gravel. So this is 5 pieces. You don't need to provide reinforcement in the tension side, pero in this case, kasi we have to provide stirrups. Anyway, hindi given do sa problem kung ano yung mga yung ultimate shear. So, hindi na natin concern. Ang pinade-design lang niya is yung longitudinal bar. So, itong reinforcement natin dun sa taas, pwede na nating i-consider yung pinakamaliit na size. So, pwede niyong ilagay 10 mm na bakal or whatever para lang ma-contain yung stirrups. So, this is 350 mm. And then, of course, we've got this is 650 mm plus the 60 mm of minimum concrete cover. So most likely ang total weight, total dimension nito is 710 mm na beam. So 350 mm. So this is the stirrups. This is the stirrups, and then you have the 5 pieces of 28 mm diameter RSB here. So this one is dowel na lang para lang meron siyang pagkapitan yung stirrups. Any question? Do you have any question? So again, dito sa computer software na to, pwede kayong gumamit ng iba-ibang mga nakaset, isinet ko lang siya ng in English, pero pwede naman tong malipat sa pwede naman siyang malipat into SI unit. So these are examples of how you're going to choose kung ano yung gagamitin ninyo. So kung meron kang steel deck or kung meron kang reinforced concrete, so pipili ka lang. Okay? So, kailangan alam nyo muna yung plano para yung plano dito, yung nakalagay na layout sa plano dito nyo ilalagay. Okay? Any clarification? Would you like to have another session ng 3:30? Sige, sige. So, let's try on this. Yung 3:30 natin. Pero you have to continue doing this and I will be posting in the Google Classroom kung saan nyo pa pwedeng i-post yung inyong output. Okay? Sige. So, if you don't have any more question, we are going to discuss one more problem here. Design for RC beams. Design for reinforced concrete beam. So, according to this sample problem, we have a reinforced concrete beam and it has a width of 350 mm. So the width is 350 mm. Effective depth of the tension reinforcement is 650 mm. So that is the effective depth. Then we have a compression reinforcement requirement to be placed at a depth of 60 mm. So meaning this is the concrete cover that we are going to use. By the way, the concrete cover is dependent on the type of structural member that you are going to design. The code and the specification or the NSCP has different requirements for the minimum concrete cover. In this particular case, however, it was specified that the minimum concrete cover used was 60 mm. So if the compressive strength of concrete is 30 megapascal, so this one is FC prime. Compressive strength of concrete is 30 megapascal. And the yield strength of steel is 410 megapascal. So you have Fy here. We are going to design for the longitudinal reinforcement. So when you say longitudinal reinforcement, okay, so this longitudinal reinforcement is to support a bending moment of 60 kilonewton meter. So that means this is our moment. This is ultimate moment. The bending moment is 60 kilonewton meter. So again, we have a width of 350 mm. Effective depth is 650 mm. The concrete cover used is 60 mm. FC prime is 30 megapascal. The yield strength Fy is 410 megapascal. And the moment that should be supported by the section is 600 kilonewton meter. So what we are going to do is to design for the longitudinal section. Okay. So we've got a 350 mm here. Okay. We've got a 350 mm here. Let me just spin this one. So the 350 mm for the width of the beam, effective depth is 650 mm. FC prime is 30 megapascal. So that is the compressive strength of concrete. Fy is 410 megapascal, or the yield strength of steel. And the minimum concrete cover, the moment is 600 kilonewton meter, and the minimum concrete cover is 60 mm. So the effective depth is 650 mm. So what we are going to do is to design for the longitudinal bars, meaning we are going to determine how many bars do we have to provide in the section. So given the value for mu, you can check on the value of W, which is a design coefficient. Mu is equals to theta, FC prime BD squared W, 1 minus times 1 minus 0.59 W, wherein mu is the ultimate moment to be supported by the section. Theta is the strength reduction factor. Fc prime is the compressive strength of concrete. B is the width of the beam. D is the effective depth of the beam. W is the design coefficient. So what we are going to do is to solve for the value of W because we are already given with the other values. Ang natitira na lang sa atin na hindi nabigay ay yung value ng W. So what we are going to do now is to determine the value of W. You would notice that we have here an equation which would require the use of quadratic equation. So the formula of the quadratic equation formula, if you can still remember, this is the quadratic formula. B, negative B plus or minus square root of B squared minus 4AC over 2a. So this is the quadratic formula. You're going to use that to determine the value of W. So the value of W, if you're going to use the quadratic equation, this would become the coefficient A, this is coefficient B, and this is coefficient C. So you solve for the value of W by quadratic equation based on solution. You can have a value of W which is equals to 0.1632. Okay, so this value of 0.1632, which is a design coefficient for ductility of the member, shall be used to determine the area of the bar. How do we determine the area of the bar? We need to find out first the steel concrete ratio. The steel concrete ratio has a formula of WFC prime over Fy, wherein W is the design coefficient for ductility, Fc prime is the compressive strength of concrete, Fy is the yield strength of steel. So based on computation, the value of rho is 0.012. This value of rho shall be used to determine how many bars do we have to provide in the section. But first, we have to check whether the section should be provided with tension reinforcement only or do we have to provide compression reinforcement? Kasi merong dalawang klase ng beam. One is a beam reinforced for tension lang or both for compression and tension. So, pwede kasing nandun lang sa tension side yung bar, pwedeng wala dun sa compression side. But in actual construction, kung hindi man kailangan ng compression bar, nilalagyan pa rin ng compression bar only for the purpose of having the stirrups contained in each place para lang merong mapagkapitan yung stirrups na ilalagay natin. So, at any rate, our aim here is to design for the beam and we need to determine whether we have to provide tension reinforcement only or do we have to provide compression reinforcement. So how do we do that? We double check the value, the actual steel concrete ratio that we have computed here with the maximum requirement. So the maximum requirement for the steel concrete ratio is 75% of the balanced steel concrete ratio. So 75% of balanced steel concrete ratio is 75% of 0.85 FC prime beta 600 over Fy times 600 plus Fy, wherein the value of beta is dependent on the value of Fc prime. In this case, because the value of Fc prime is 30 megapascal, then the value of beta is 0.85. So those are the codes and specifications. So if you have here, the value of beta is 0.85, Fc prime is 30, then Fy is 410, then you can proceed with the determination of the maximum steel concrete ratio. According to computation, the maximum steel concrete ratio is 0.02 0.36. So we have to check comparing it with the actual steel concrete ratio. So if you are going to compare the actual steel concrete ratio with the maximum steel concrete ratio, if the actual is less than the maximum steel concrete ratio, then we can provide only for tension. So the reinforcement, ibig sabihin, maglalagay lang tayo ng bakal ay dun sa tension side only. So pwedeng dito na lang tayo maglagay, dun sa taas, pwedeng hindi na tayo maglagay. But later on, as I have mentioned, in actual construction, hindi naman tayo naglalagay ng biga na isa lang yung bakal dun sa ilalim simply because we have to provide stirrups. And to contain the stirrups, kailangan merong mapapagkapitan yung stirrups dun sa taas. Okay? At any rate, let's go back to this one because we have the steel concrete ratio is the actual is less than the maximum steel concrete ratio. Then we can proceed into the determination of how many bars do we have to provide in the section. So you have here the area of the steel bar simply equals to rho times B times D. That that was taken also from the formula of rho wherein you have AS over BD. So area of the steel bar and area of the concrete. So that's why it's called the steel concrete ratio. So area of the steel divided by area of the concrete. The area of the steel, for us to provide a balanced condition, ibig sabihin lang, ang principle, yung area ng steel bars na provide natin is proportionate to the area of the concrete na nandun sa section natin. So that is balance condition. So in this particular case, since we are going to use the steel concrete ratio is 0.012, you multiply it by the width of the beam, which is 350 mm, and the depth of the beam, which is 650 mm. So the area is 2,730 square millimeter. Okay, so that means this area is the total area of the steel that you have to provide in the section. So you can use the beauty of designing is that if you have a preference of the size of the bar that you're going to use, you may do so. In this particular case, let us try using 28 mm diameter RSB. Okay, so if you have a 28 mm diameter RSB, we can now determine how many bars do we have to provide in the section. So the number of the 28 mm diameter RSB shall be multiplied by the area of one bar, so which is pi d squared over 4. So that's why you have pi over 4 times d squared is equals to the area of the steel that we have to provide in the section. In this particular case, according to our computation, we need to provide 5 pieces of 28 mm diameter RSB. Kung halimbawa ang nakuha nyo lang dito halimbawa ay 4.6, mag-round off kayo doon sa mas malaki. Okay? Hindi naman tayo po pwedeng maglagay ng bakal na 4.6 na peraso, 4.5 na peraso ng bakal. So that's why you need to round it off dun sa mas malaking, mas madaming value. So kung let's say 4.6, round it off to 5. Kung 4.3, round it off pa rin sa 5. Okay? So you have 5 pieces. Do we have to provide 5 pieces of 28 mm diameter RSB? So meaning if you are going to draw your section, this will be your section. You have to provide 1, 2, 3, 4, 5 pieces of 28 mm diameter RSB. This section is 350 mm by 710 mm. 710 kasi 610 mm plus yung 60 mm na concrete cover natin. Okay? So this is the designed section. So what you're going to do with your computation is that we have dun sa inyong design, all you have to do is to show yung design nyo ng beam, design ng column. You don't have to provide the design for the slab doon na lang tayo mag-concentrate sa design ng beam at sa design ng column. Okay? Ayan, magre-record lang ako para alam ko kung sino. Kasi hindi nakikita doon sa recording yung mga wala sa video cam. Naka-flash, naka-black out pag hindi naka-open ang video cam. Kaya hindi ko rin malaman kung umattend ba o hindi.